Okay, so just from like the questions that people are asking, I think there's a few things that we're not really understanding very well. And the first one is what I told you was the hardest part of vector addition. And you didn't believe me, but now I think maybe you will. Drawing the picture is the hardest part. Okay, getting the picture right is important because you won't get the math right if the picture isn't drawn. Okay, you'll use the wrong trig functions or you'll invert them and they won't give you the right answers. So, just to clarify, when I'm giving a direction, how do I draw my vector and my triangle? So, if I give you this number, 26 meters at 49 degrees west of south, okay, how do I draw that vector? The first thing I have to look at is, what is my reference direction? What's my reference direction here? South. South. South is my reference direction. So what I do is I draw a reference line that points south. Now it says my vector is going 49 degrees west of south. That means it's over here somewhere. Okay, 49 degrees in a westerly direction from south. Now I've got my triangle. Okay, whatever that second direction is, that is your reference direction. Okay, and that is where you will measure the angle you're given from. So let's say I get this one here, 22 meters at 16 degrees north of west. Which direction should I draw my reference line? West. Okay, I'm going 16 degrees north of that. That's 16 degrees north of west. Okay, then we kind of follow me on how we draw those. Okay, and then if I have another vector on top of that, as my second vector, and I'm just going to draw one here. Okay, so let's say it just looks like that. Those are my two vectors. Okay, where do I connect them? Start to end. Okay, so they go from here to here. Okay, now I can draw my resultant, that's the green line. Okay, I can draw its triangle either here, which would be the logical place to draw it because it doesn't interfere with my drawing over there. Or I could draw it down here. Those are similar triangles. Okay, the only difference is this angle will be west of north. This angle would be north of west. Okay, that's all that's going to change. The sides are going to be the same. Okay? So now that I've got that drawn, now I know what I have to do from there. Okay? And I'm sensing people are really struggling with drawing the diagram, and that's not unusual. Okay? It takes a bit of practice to draw the diagram. That's why we spend so much time doing vector addition. I know it gets kind of boring if you get it, because like, oh my God, I know how to do this, and I don't have to keep doing it. I get that. Okay, but it is something that can be a bit troublesome and tricky when we're trying to do the drawings. Okay? All right, that makes sense. Are there any other like kind of fundamentals questions that you'd like to ask about doing vector addition?
Like saying what direction it is at the end.
Okay, so that's what but I'll go over it again. That's what I just did. Okay, so with this triangle, this is my result now. Okay, this is the angle here. Okay, and I know this is the angle I want to find because it's the one that tells me how to get from my initial position to my final position. Right? I always want to look at the angle that is nearest to my starting point. What I often say to people is, circle your starting point, and wherever that circle goes through your resultant's triangle, that's the one you find. Okay? Now, as to which direction is that, well, the main compass direction that it touches is north. And it's going west of north. Okay, so look at your angle arc that you draw, and whatever main compass direction it touches will be your of direction, the second one. Okay, and you're gonna move in a direction from that. So this is west of north. Okay, all right, any other questions there, guys?
Wait, so would we calculate the red triangle as well?
Yeah, you would have to, in order to calculate all this, you'd have to calculate the black triangle, the red triangle, use the black X and red X to get green X, same as we did on all the others, yes. Yeah, I just didn't do that, we were just kind of looking at theoretical values for that. Okay? Don't be afraid to ask, guys. I mean, this is one of the trickiest things in this course, for sure. All right. Now, yesterday, we ended off, and we were working on D, and I think we finished D at the end of the day yesterday. Or did I just draw the diagram?
You drew the diagram.
Do the diagram. How many people are done D from yesterday? Okay. How many people would need a little bit more time to finish D? Okay. I'll give you guys a couple minutes while I draw the diagram out again, and then we'll walk through it, and then we'll look at E and F. Okay? Alright, so that's what your diagram for D should look like. Okay, we go 12 meters south, and then we go 15 meters at 55 degrees east of north. Okay? Now, scale is important on this diagram because it can be misleading. I have a lot of people, when they draw this, they draw it getting back even with the top or past the top. Okay? This is 12 meters straight south. There's no way I'm going to go more than 12 meters back north on a 15-meter vector angled more than halfway down. Okay? It's just a matter of kind of recognizing stuff like that. It takes a bit of experience, but okay, that's what we would look at for that. No question. Okay, let's look at the rest of D here, just so we can see how the rest of it goes. Right. So I've got to find black X, black Y, red X, and red Y if I'm going to get, I'm going to have to find black Y and black X in order to find red X and red Y. Right? So first thing I'm going to do is do green X, 0 meters. If I go due south, I don't go east or west, so there's no X value here. Right? And then the Y value is 12 meters south, because that's exactly what I do. I go straight south. For the black triangle, I've got to do a little trig. Okay? Black X is opposite my 55-degree angle, so I'm going to go sine of 55 times 15 meters. Okay, so that side is 12.287 meters, and that is east. And then black Y is adjacent, so it'll be close to 55 times 15. Alright, so it's 8.604 meters north. Right? Now that that I've got all the x's and all the y's, I can get my resultants x and y, that's red x and red y. Okay, so to get that, I add the x's together, so 0 plus 12.287 is 12.287 meters east. Okay, because black x and red x are equal according to this diagram. George?
For black, why, I got the same answer, but I did Pythagorean theorem.
Don't do Pythagorean theorem. You're gonna get similar answer, but it's not gonna be the same number of decimal places. When we start doing Pythagorean theorem for the end and trig for the end, those decimal places will matter enough that you'll get a different answer. Okay? Okay, and then we gotta do red y. Okay, red y, I've got 12 meters south, and then I've got black y, which is 8.604 meters north. Okay, so those have to be subtracted. So 12 minus. And give me 3.396 meters south. All right, so I know this side is 12.28, and this side is 3.396. Now that I have those, now I can use Pythagorean theorem to get my overall displacement. Okay. Squared plus that one squared. Okay, so we're looking at an overall resultant that is 12.748 meters long. Okay, and then we need to get our direction. Okay, so I'm going to use tan to calculate that. Y is my opposite side, x is my adjacent side. So that'll be 10 to the negative 1, theta equals 10 to the negative 1 times, in brackets, 3.396 divided by 12.28. Alright, so we're looking at a 15-degree angle there. And the way I have this drawn, that 15-degree angle is south of east. Okay, so my final answer here is going to be 12 meters at 15 degrees south of east. Okay, and I don't know why I have 13 on there, but we can't.
You messed up your 12.
Oh, did I?
It should be 12.7.
12.78, yeah, so it should be 13, yeah, okay. Right, it was 748, not 478, right?
It was 748.
748, okay, so that should be 13 meters at 15 degrees south of east, or at 75 degrees east of south. It depends which way you drew the triangle, either one of those is fine. Okay? How many people have done the next one? All right, I'm going to give you guys a few minutes. I'll draw it right now. Okay, I'll draw E right now, and then you guys can see how you're doing with that one. Okay, if you're done E, move on to F. If you're done F, this is in your worksheet booklet. Move on, okay, to question number 4. All right, remember we also talked about both questions yesterday, and there's a few of those on that worksheet as well. Okay. really long enough. Okay, so E should look something like that. go over E? Yeah. Oh, it's been running the whole time. Recording silence. Making use of memory. Okay, so we have to find all of our x and y components. So our first x component is black x. Okay, and that's going to be the cos of 26. If it's the adjacent side, times 5 meters. Alright, so 4.49. I feel like we did this one yesterday. Did it feel right? I think we did. Yeah. We did.
No, it- not-
We didn't do
not
the
to
last
F.
one.
Not to
Yeah.
F.
Yeah. That's what we did. Okay, I'm not gonna do that one again, because we did it yesterday. I'm looking at that and going, I used that as an example of why scale was important yesterday, because you had to make sure that you drew the 7-meter one long enough. Okay, that you had class with. All right, how many people have done that? Okay, are we ready to go over F, or do we need more time?
More time.
More time.
More time.
Okay, I'll give you a little bit more time. Okay, I'll draw F right now, okay, and then maybe by the time I'm done drawing it, you'll be ready. Okay, that's what the diagram for F looks like. Okay, I'm just gonna walk through the rest of F here. Okay, so black X is the adjacent side, so that'll be the cos of 35 times 9 meters. Okay, y is the opposite side, so that'll be the sine of 35 times 9 meters. Okay, for the red triangle, x is also adjacent, so cos of 25 times 7. And that one's east, and then the y component is the opposite side, so sine of 25 times 7. So. Okay, so now I've got all my x's and all my y's. Okay, now I can find blue x and blue y. So for blue x, okay, I'm going to take black x and add it to red x. They're both east. Okay, so they can both be positive here. Okay, both of those things go east. So my overall direction in the x component is east. So that will be not 7.37 plus 6.34. Okay, so 13.717 meters east, and my y components I will have to subtract or add the making one of them negative because black y is north, red y is south. Okay, so I end up only going a little ways north of where I started there. Okay, so I'll have my 5.16 plus negative 2.96. For now. Okay, so we're going to take that 5.16 and I'm going to subtract 2.95. Okay, so we're getting 2.20 meters north. All right, so now we've got our resultants, x and y. Now we can find our overall resultant value using Pythagorean Theorem. Okay, so big D will be the square root of 13.7 squared plus 2.2 squared. And so we're looking at 13.9 meters for our overall displacement magnitude, and then I've got to find theta. Right, so for me, that'll be 10 to the minus 1 of the opposite side, which was 2.2, divided by the adjacent side, which was 13.7. And then I'll put in my angle. Okay, so I'm getting a very shallow angle, which fits with my diagram, okay, of 9.1 degrees north of east. Okay, so I'm getting a final answer here of 14 meters at 9.1 degrees north of east. But I would also accept, and I think it's the one that's on the sheet, 81 degrees east of north. Same number of significant figures. I know it doesn't look the same, but it's the same number of significant figures. Okay. Everyone kind of follow me there? Any other questions on that one? That would be about as involved as they would get, having two of them that are angled like that. Okay. You have to do the most calculated with those. Okay, one like this one's pretty straightforward. Okay, why is this one so much easier than the one we just did? This one's perpendicular, is it not? They actually told me, here's the x component, here's the y component, find the overall result. Okay, just because the resultant is velocity doesn't mean I change what I do. Okay, and this one here, it says the east component is 15 meters per second, the south component is 11 meters per second. Okay, so this is x, this is y. And my resultant goes like this. Right? And I just do Pythagorean Theorem. This time, instead of getting displacement, I'm getting average velocity instead, because the two vectors were velocity vectors instead of displacement vectors. But it doesn't change the fundamentals of what I do. All that changes is at the end I get meters per second instead of meters. Okay, so don't let that throw you. We do a lot with ones that are displacement, but it's the same for any vector quantity. Okay, questions on 4? All right, see if you can do that one. Also very easy. You're just being asked to find x and y here. We'll give you a couple minutes and we'll make that our last one. Okay, so we've got an escalator. Things are going like that. Okay, the 2 meters per second. Angle is 35 degrees. Here's x. Here's y. Okay, we're just being asked to calculate the horizontal component and the vertical component. So the horizontal component, cos of 35 times 2. Y component, sine of 35 times 2. Okay. should give us those two numbers, okay? That's how fast she's going over and how fast she's going up, okay? As she rides the escalator at a diagonal, okay? Everyone all right with that? Thanks, that's just finding X and Y, you guys are good at that. All right, tomorrow, we may start something a little bit different. We're still gonna be working on vectors for a while, but I don't want you to get like super bored of doing this problem after problem after problem. So we may start a bit of a kind of group activity using maps tomorrow, just to kind of break it up a little bit. Still uses vectors, but at least we get to do something different and work with others. Socialize a little. All righty. We're also tomorrow going to talk about the acceleration labs. I must admit to feeling a bit unheard. Okay, I wouldn't laugh. Yeah, I feel a little unheard because people are making the same mistakes that I went over on the first lab, and there were a lot of things that I kind of just gave away or said, hey, this is really important, make sure you do this, and people didn't do it. Okay, that's why I feel a little bit unheard. Okay, so that's like my thing to deal with, but your thing to deal with will be the repercussions of that, because then there were things you didn't do right, and as a result lost some marks in the analysis. Okay, so we got to look at that stuff. Velocity versus time graphs still seem to be giving us a lot of trouble, and we don't have a lot more time to spend on them. So we'll have to pay close attention